A computer program is a list of instructions that can be followed by a computer to perform a specific task. Most programs work by taking some input data, processing that, and creating some output data. Understanding the values and types will form a foundation on top of which we can build up concepts that will allow us to write our own programs. So values are the actual underlying raw numbers and text our program manipulates. Tony Stark, the number 43, and false are all examples of values. Sometimes we'll say that when we literally write the number 4 and then the number 3 next to each other to form the number 43, that we're writing the literal 43. Same with Tony Stark. If we write the quotes, then the letters T, O, N, Y, etc. into our code, we'd say that we're using the string literal Tony Stark. Sometimes we might say that this is hard-coded, meaning that when the program runs, the literal value isn't going to change. Literal values are used a lot when you're first starting out, but eventually data will likely come from a database or some user input. Every value belongs to exactly one data type. The kinds of values that can be represented and manipulated in a programming language are known as types. All of these literals that we've written so far can be categorized as a specific type. We see string, number, and Boolean. Those are the types for Tony Stark, 43, and false. Most languages use a very similar list of super simple types, like a collection of characters as a string of text, a list of digits with or without a decimal point as a number, and then some type for representing true and false. Some programming languages will have more types that they have built in. Other programming languages will have a very small set of these primitive built-in types that you are to use to build up to more complex types. When a program needs to use a value again in the future, it assigns that value, or sort of like stores that value, in a variable. Variables have names, and they allow us to use those names in our programs to refer back to the values. We'll talk more about variables later. Here we're assigning the value 7 a name, age. We're also assigning the string Grayson to the variable name, first name. If we wanted to print out the value 7 using the variable age, we might call some print function and pass in the variable name or the literal number 7. And we'll take a look at how to print out the number or the string or whatever value it is in different programming languages. There's really two different kinds of types. There are built-in types, and then there are user-defined types. Built-in types are the types that come with the language. This is the batteries included stuff like numbers and strings and dates and arrays and object types. User-defined data types are defined in terms of built-in data types and other user-defined data types. Here we're defining a student type, or we have defined a user-defined type called a student type, which is composed of or made up of other built-in types, the number for the age and the string for the first name. We might also create a car type, which takes in a make and a model, both of which might also be user-defined types. Typically, a programming language does not let the programmer extend or redefine those built-in types. Next, a type can either be mutable or immutable. These primitive types like 7 and true are immutable, meaning they cannot change. You can change the value of the variable, meaning you can change what the name of that variable is referencing by pointing the variable at a different value. However, there's no way to change what the number 7 means. When we talk about the number 7, there's no way we can modify the number 7 to be the number 8 or the number 6. We wouldn't want to change what the number 7 means. Similarly with true, we wouldn't want to change what it means for something to be true. A mutable object can change. Here we have an array or a list, And this list has 4 values. It has 9, 10, 9, and 11. These might be ages or these might be other values, but the underlying type for this collection of values is called a list. A list or an array in some languages can change. All right, let's learn how to work with values in Ruby. Today I'm working with REPL.it. It is a tool that lets you execute Ruby programs. On the right side, we have a pane which represents our terminal output. In the middle, we have a pane that represents our editor. Main.rb is the file that we're going to be editing, and when we click run, it will execute our Ruby code and show the output on the right-hand side. If we click run right now, we have no code written, so there is no output. It shows us that it ran the command Ruby, and the input file name was main.rb. The very first thing I want to do is print something to the console. So I want to, I'm going to use the puts method, or the puts method here, and pass it a number literal. So we're just going to pass it the number 1 and click run. And this will evaluate the expression 1, find out what the string value should be for that, and print it out to the terminal. So we see 1 show up in our terminal here. The next thing I want to show you is how you can add comments. So by adding the octothorpe, we are commenting out this bit of code. So we can add this, the pound sign or the hashtag sign, the octothorpe, whatever you want to call it, at the beginning of the line to start the beginning of a single line comment. So we are commenting out this code. Comments are generally used to describe what's happening in your code and make it easier for a human to read through your code and for you to remember what certain code is doing. So here we're commenting out puts1 so that I can keep track of and share with you the different commands that we have run so far. So I'm commenting out puts1. I'm going to make a new line by hitting enter. And on this next line, I'll show you just another simple example. We're going to say put s, the number 43 from our earlier example. And you'll see that 43 prints out to our terminal. So that's great. The next thing I want to do is print out the name Tony Stark. So we'll say put s Tony Stark and then execute. And you'll see what happens here is we get an error and it says uninitialized constant Stark. And that is a name error. So it's one really important thing about programming in general is being able to read an error message and try to understand what the computer is telling you about what it tried to do and what it was unable to do and like how it failed. So in this context, we're calling the puts method, this built-in method, and we're passing in a value. And the value that we want to give it is a string of characters for the name Tony Stark. But when the Ruby interpreter is running this program, it doesn't actually know where the string is starting and where it's ending. So here we need to use some quotes to wrap the string. And when we define the string literal and pass it into puts, we want it to know where the string starts and where the string ends. So in Ruby, we can use single quotes to define a string literal. We can also use double quotes. There's also a couple other really fancy ways to create strings in Ruby, but today we're going to work with just single quotes and double quotes. The primary difference being with double quotes, you can do this fancy thing called string interpolation, which we'll talk about much later. So we have our single quote at the beginning that tells us where the string starts, and our single quote at the end telling us where the string stops. And we're saying to print that string to the console. So if we run this now, we'll see that Tony Stark is indeed printed to the console. So that's great. All right, so what else can we do here though? So one thing that we might want to do is show that we can, if we use a double quote in the beginning and a single quote at the end, if we try to run this code, it will fail again because the ending quote, the style of the ending quote needs to match the style of the beginning quote. If the beginning quote is a double quote, the ending quote also needs to be a double quote. If the beginning quote is a single quote, the ending quote also needs to be a single quote. So here we have a double quote to begin and a double quote to end, and we're able to print out Tony Stark. Great. Let's keep going. So we have another thing we can show is that we can print out an expression. So if we say 43 plus 10, we're going to print out the result of the expression 43 plus 10. So here, what's happening is the very first thing we're going to do is evaluate the expression on the right-hand side. that you can sort of think of this expression being the literal number 43, this operator, the plus operator, and then the value 10. These three things combined gives us an expression. That expression will be what we call evaluated. So the computer kind of just figures out what is 43 plus 10, and then it replaces this expression with that new value. So it will replace it with 53 before passing that value to puts, which will then print it. So if we say 43 plus 10 here and then click run, we're going to get the numeric evaluation of 43 plus 10, which is 53. So that's kind of what happens when we're evaluating an expression before passing it into puts. So we're using two number literals and the plus operator, and that gives us kind of like the arithmetic output that we would expect, just like from math, from what we know from math. Okay, so this is also useful when we're working with strings. So we can say puts Tony plus Stark, and that will evaluate Tony, the string literal Tony. So we're going to use a string Tony, then the plus operator again, and then Stark. So in this case, there is no mathematical way to add Tony and Stark, right? But we can use, in Ruby, the plus operator will perform this thing called concatenation. And so concatenation is the linking of a series of things together. So we are going to concatenate the string Tony with the string Stark. And if we click run, we'll notice that the output here is Tony Stark, and there's no space between Tony and Stark. There's no space between the first name and last name because in the strings that we concatenated together, there were no spaces at the end of Tony or at the beginning of Stark. So if we wanted to print out Tony space Stark, we could either put a space at the end of this Tony string or at the beginning of Stark, and then when we run, we get Tony space Stark. Another alternative would be to say Tony plus the empty string, or like a string with a space in it, plus Stark. So this is going to be, we're going to evaluate this expression, so we'll have space Stark, and then we'll evaluate Tony plus space Stark, and then we'll get back Tony Stark. So we can use string concatenation here when we're printing out strings. We could also print out Boolean values in Ruby. So we have the Boolean value true. So we might just print out true, and that looks like that. Same with false. In Ruby, the values, the Boolean values for true and false are all lowercase, the word true and the word false. Let's see. We could also print out type information about the value. If we then want to inspect a floating point number like 43.123, we can print that out and we'll get back float. So this is one way that we can inspect the class type for a value.